This year, we're going to begin with a subject that should be familiar to most of you, integers. As I go through these notes on integers, I want you to take notes the Cornell way as we discussed in class, beginning with your questions on your left and the answers on the right. The first question is, what is an integer? An integer is any whole number or its opposite. Integers are part of a group called real numbers. Integers can be positive or negative, and some examples are negative 3, 1, 104, and negative 76. All of these are examples of integers. Are all numbers integers? No. Only whole numbers or the opposite of whole numbers, negatives, can be integers. What can't be an integer? Numbers that have fractions or numbers after a decimal are not integers. These numbers are not integers. 2/3, 1 5/100, 5 7/8, 2 5/10, 7/9. They are real numbers, but they are not integers. Any integer you can add, subtract, multiply, and divide. You can multiply, subtract, add, and divide all of these numbers here, but they are not integers. On the last slide, we talked about opposites as regarding integers. An opposite has the same absolute value, but a different sign. The opposite of 5 is negative 5. The opposite of negative 7 is 7. So that begs the question, what is absolute value? Well, absolute value shows how far a number is from 0 on a number line. It tells how big the number is without considering the sign. Absolute value is always positive. The symbol for an absolute value is two vertical lines around a number. An example of absolute value symbol is this. This reads the absolute value of negative 3. And the absolute value of negative 3 is equal to positive 3. Remember, the absolute value is always expressed as a positive number. So even though negative 3 is clearly negative, these two symbols here, this symbol, the absolute value symbol, tells you that you're only measuring the distance that negative 3 is from 0 on a number line. So if I were to come up here and draw a crude number line, which should be straight, but you get the idea. And I put 0 here. Negative 1, negative 2, and negative 3. Absolute value measures the distance that this number here, this integer here, negative 3, is from 0. So if I loop 1, 2, 3, I can tell that negative 3 is exactly 3 spaces from 0 on this number line. So the absolute value of any number on this number line is the distance it is from 0. So if I had a positive 100, the absolute value of it is 100. But if I have a negative 100, the absolute value of that, well, is still 100. So regardless if it's positive or negative, the absolute value is merely the distance that that number or integer measures from 0 on the number line. So why, you may ask, do we have negative numbers? Well, negative numbers gives us a way to talk about how much less something is than 0. Examples like on Jeopardy, when someone has no money and then they lose $500. Their score is negative 500. They start at 0, they lose 500, their amount is a negative value. Or when it gets really cold outside and the temperature drops below freezing, that freezing point sometimes in centigrade or Celsius is 0 degrees. So if it drops below 0, we say it is below 0 or negative value for temperature. So if it's 0 degrees in the middle of the afternoon, by night the temperature drops to negative 12 degrees, then we need those negative numbers to be able to express that value. Some other ways to use negative numbers: directions, yardage loss in football. You football fans, if you see a running back or a receiver catch the ball behind the line of scrimmage or the 0 point and they go backwards, they lose yardage. It's expressed as a negative. Money, if you lose money, it's expressed as a negative. If you lose altitude in an airplane and the airplane drops, that's expressed as a negative. Obviously, you don't want it to drop too quickly. Time, negative values. If you're losing time, you express it as a negative value. Finally, how can we compare integers? Using the less than and greater than, we can look at how we compare integers using the less than and greater than symbols. Sometimes we need to use the greater than and less than symbols to compare the numbers. If you read the symbols from left to right, it's easy to remember which symbol is which. If you come to the open end first, say greater than. If you come to the pointed end first, say less than. Practice with these. 8 is greater than 3. Negative 9 is less than negative 73, which is less than 8. And the absolute value of 4, remember that's the number of spaces it is from 0 on the number line, is less than the absolute value of negative 6. Even though 4 is bigger than negative 6, the absolute value of 4 is only 4. The absolute value of negative 6 is 6. And we all know that 6 is more than 4. So remember to go back through your notes. Make sure you've included the question on the left side of your Cornell notes and the answers to those questions and examples on the right side of your Cornell notes. Tomorrow in class, we're going to talk about how to do computations using integers.